Okay, very good. Okay, there's been a lot of confusion historically about the GLS library versus the GLS features. Owners of things like DB Access or New Era or even the server ESQL4C think that just by linking with the GLS library they're going to solve all the problems. I think the first problem you find if you're working in any kind of internationalized application, including ESQL4C itself or any of the APIs, is where is that boundary between the product and the GLS library. The GLS library has a very well-defined interface, documented on the GLS website. I assume that you all know how to get to that point, or at least you know somebody who knows how to get there. Those interfaces are well defined. There's really two sets of interfaces, and I'll talk about those later. But in terms of the ownership within our group, we have ownership of the library itself. So we own the library, and then we also own the GLS library, and we own the responsibility of applying the GLS library to any of the components that we own. So for ESQL4C, we own the whole thing. We own ESQL4C and internationalizing that, as well as the GLS library used to internationalize ESQL4C. DB Access, same thing. We own both the library that helps you internationalize and DB Access itself. For example, for the server, we don't own internationalization of, say, RSAM or any of the on-utils, for example. We own the GLS library, but an application of that technology to those tools is the responsibility of the owners of those.
How about things like, are there any parallels between like GenLib, where if there's a GenLib function that happens in the server, we are, or ORSLib, we are then responsible for it?
Yeah, the parallels are great because when we started to create the GLS library, we did it under the assumption that we would have one library used in all contexts: tools, connectivity, server, and there would be one owner of that library. There would not be the historic split of things like GenLib. Like, 4GL owns a copy of GenLib, server owns some parts of GenLib, we own the majority of GenLib. We wanted to make it clear that there was only one GLS library, not only one source, but even one object. So there is, if you compile a GLS library, you could do a separate build. That thing could then be used to link in all different contexts.
So they use the lib gls.a or whatever that is built, the same one?
They being?
The server.
Yes, exactly the same, for client and server. And I'll talk about, I may forget to come back to some of these issues, so please, if you have questions, take notes on this, because since I haven't prepared, things like how do we achieve the same library for the client and the servers, and I think an important issue that we can come back to. But yeah, the client and the server share one version of the GLS library, one source, one build. CM has had problems working with the GLS library. They have not seen such a shared component before. It's always they've always had the in some projects they've had the impression that if you need a component, you need to build the component. And that's not the case with the GLS library. If you need it, you can just take it off the shelf and take something that's been built in a separate VOB and a separate build structure. And the GLS library does have its own VOB, its own separate structure. Like I said, the difficult part is to determine what's the ownership of a particular area. I think there's still people who historically associate my name with anything to do with GLS, even if it's in their own product, having nothing to do with the GLS library. And some people have the belief that because we own the GLS library, we own describing to them how they should apply it to their product. And that's really a bottom-up approach that is not applicable. It should be top-down, in which they look at their customer base and they find out for, let's take, I don't know, any product. the server. They have a customer requirement from an international requirement. They need to figure out how that international requirement is packaged in their product. Once they figure that out, then they have to figure out how to implement that. Some of that stuff may involve the GLS library, some of it may not. The GLS library in that scenario only comes in at the end phase. They're trying to, I've seen a lot of teams use the library and its documentation as sort of a functional spec for internationalization of their product, and it's the farthest from the truth that it can be. They have to develop their own functional spec. This, of course, would be part of the design spec phase of implementing that feature. So you may see, if you've got your fingers on the library somewhere and somebody's associated your name with it, you may get questions like, well, should I use Unicode or whatever? Should I, how should I implement this stuff? How should I design this stuff? It's not a question we can answer. When I was heading that group, those were the kind of questions that we would consult with people on. But we don't answer them right now. The person to point people to is Gil Peratt.
Is he the person?
Yeah. I mean, he's the kind of top-down guy. Unfortunately, he's part-time, and he used to work for me, and I had a team of people who I'd send out to consult with various groups, ESK4C group being one of those back in the early days. But he's the only guy that can do something like that right now. And so I've referred, over the 2 or so years since I've been involved with GLS, I've referred people to him for those kinds of issues.
Did you used to answer questions like, someone says, oh, I'm having a problem with so-and-so locale. It's not working for, I'm having a problem doing such and such with this locale.
Yeah, well, there's 2 types of locales. One where the definition of the ownership is clear, which is all the international locales, like the Japanese locale or the French locale or even the English locale. Those are responsibilities of the Dublin team.
Okay.
So the GLS library, when it's built, builds from C source code. It builds shared libraries and archived libraries, and it also compiles and includes in what's called the GLS dist. This, of course, to the SQL dist. It includes compiled versions of the locales that have been created by Dublin. If there's ever a locale problem, we don't answer it here. The appropriate thing is a PTS bug where the product is GLS live and the component of that PTS bug is either locale for locale, cconv, I think, for code set conversion, or CMAP for char map. Something. Those are the three types of GLS text files that the Dublin team is responsible for. So if anybody says, I don't like the way the Japanese locale is structured, that's not our problem. We pass that immediately on to Dublin, even though we are the vehicle by which those locales are delivered. That's really more of a packaging thing than anything else. We own the locale compiler, the thing that takes this locale source and compiles it to an object file, and those object files eventually get loaded by the library runtime. We own the compiler, so there have been some recent questions about maybe the formats of locales need to be extended to have more information, but most of the questions are, I don't like the way that the Taiwanese locale was created. I don't like the sort sequence in the French locale. It's not our thing to agree about. Although people will ask us about it, we just have to make sure we've channeled them in the direction. Because like I said, anything GLS, people will do the kind of shotgun approach to say, who's the last person I heard the term GLS associated with, and they'll ask that question. So I've had to do a lot of referral. So anyway, that's just the way it is. I think that it's just like in PTS bugs. You could send out as much information as you want to users about when you have a problem with this particular product. This is how you report the bug or whatever. We could do the same thing with the GLS library, but unfortunately, until people have a problem in front of them, they don't really care about that information, so they won't have read it initially. So it's usually an ad hoc approach, unfortunately, to getting these problems resolved. And many problems with the GLS library, or the locales, or anything related to GLS, usually clang around. They start in the country, go to a country manager, sort of go to a few people that they know here, kind of bounce around a little bit. So unfortunately, by the time you get to a particular GLS problem, it's been escalated through a few levels of management. So that's just the nature of the fact that there's not clear tech support channels that undercut management. It's usually, it goes from the local tech support up to their management, across to management, in tech support down, and then, so usually by the time you get that step, it's escalated too high. Back to more of the mechanics. The library is one single source for Windows and Unix. There are if-defs, of course, for the different platforms. We did have a Windows 3.1 version that's out there somewhere. The building of that has been very difficult. Possibly Rulon could help out with that, but I don't think there's been a need to rebuild on Windows 3.1, and if there was, I'd be worried about that, because with the memory models and we tried our best with 8.3 file format and stuff like that, and case sensitivity. We've got some problems there, but certainly on Win32 and Unix, it's no problem. We used to have better CM support. They used to do nightly builds for us on Unix. They never did nightly builds on NT. We've always had to do our NT builds, still to this day. And I think they can do our Unix builds for us, but we have to request that of them. It's not something that happens on a regular basis. Because basically a particular version of the client SDK or the server will lock in on one version of the GLS library and stay with that. CM does it in a weird way. I think they rebuild the GLS library every night with a particular server or client. I think they do that, but they had the same config spec for maybe 6 months, so they just keep rebuilding the same config spec, and given that there's very little reliance the GLS library has on any other components, it just continues to build, so it's the same, burning a hole in the same part of the disk day after day, doing the exact same thing. I think as part of doing the Mac ESQLC port, Shade Tree, the third-party company that we've outsourced the Mac to, has built the Mac version of the GLS library. Not as a separate unit, but just for the purposes of ESQLC, making ESQLC. I don't think OS2, I think the only OS2 ports are like 7.1 or 5.0 or something like that, I think. I'm not sure. Maybe there's a separate OS2 port. Let's see. GLS library is used by 64-bit platforms. It's already been tested as 64-bit clean. Although based on some information that Shane and I were looking at this morning, we have some concerns about 64-bit and the data type. GLS library uses the data type, so it may have the same problems as ESQLC regarding 64-bit platforms. And it may not have. How we achieve client-server independence is the GLS library. Well, let me give you a little bit of history and then go from there. When we try to figure out how to do internationalization across different operating systems and different Informix products, we had to either rely on the internationalization support that was in the operating system, or we had to build it ourselves. The way we saw that there was variations in the way Sun did internationalization, HP did internationalization, DEC, IBM, DOS, Windows 3.1, Windows 95, Windows NT, all those operating systems presented a slightly different API, although they're pretty similar API, slightly different API, certainly different semantics. if you're talking about being consistent in client-server mode, the definition of French on HP was different than French on IBM. So if you try to talk with them on the network, there'd be two confusions. One is the name used for the locale was different, so you couldn't even figure out whether French was French. I say French, and everybody understands what that means, but in IBM it's like FR_FR.8859-1. On Sun, for example, it's FRENCH. And we could have thought of creating mappings of the names, and not only that gets into some combinatorial problems, but also, like I said, the definition, the semantics of the libraries were themselves different. So, for example, if you had a date format that you wanted to parse, you wanted to send from the client to the server, you would have to make sure that those same rules were applied on this client and server, and we couldn't get that consistency. So we decided, and also those libraries had a function called setLocale, which loaded a locale and set a global variable, and then every other operation after the setting of that global variable would operate on that locale that was loaded. The problem with that, of course, is in a multi-threaded environment, you can't have globals. The operating system people solved that problem, obviously, but they only solved that problem if you're using their operating system threads. And we, of course, on the server weren't using operating system threads, so we needed a thread-safe library that didn't use setLocale, so the only way we could do it is to create our own. And I think in retrospect, for the server, that was a good idea, because the server shouldn't really have its own characteristics. The characteristics of the server shouldn't be tied so heavily to the platform. The server should be pretty neutral, and it should be driven by the data that comes from the client or needs to go to a particular client. If you start saying that a Sun server has so many Sunisms that when you try to access it from a PC, it doesn't look right to the PC user, then you're really penalizing the ultimate application. So in general, to follow that general trend, we said, well, let's create a GLS library that can mold itself to whatever the client wants to be, put that in the server, control our own multi-threaded environment. And so if somebody wants to put in PC data in a database that's on HP, the HP-isms aren't going to fight against the Windows-isms. So anyway, because of that, we wanted client-server consistency, we wanted multi-threading. All the internationalization functions that were part of the operating system didn't take a locale as a parameter. They just simply said, well, I'll look at this global over here and I'll operate as I do in that global. And we just couldn't have that. So we had been to some standards committees meetings where they were talking about making a distinction or adding a locale parameter to make a thread-safe version of the internationalization functions. You'll find many of the functions that are in the GLS libraries, the models for those functions, in the ANSI standard or in particular operating systems, because we derived our information from there. Our main model was the XOpen standard. And you know how the standards committees for procedures. POSIX is similar to XOpen, which is similar to ANSI. There's enough similarities there, but enough differences, so we chose the XOpen model. And XOpen also defined formats of locale files and things like that, which was convenient for us, whereas ANSI simply defined the interfaces, but didn't define how to create a locale for French or a locale for Spanish. In terms of the locales, they've been all written by us. Well, that's partly true. We needed to define locales that would work in a heterogeneous environment. So we had the Dublin team create these locales. There's also a set of locales that are created called the NLS locales, operating system locales. Before the 7.2 product, I think it was 6.0, was internationalized by company Siemens Nixdorf in Germany, internationalized for the European market, the single byte European market. And the way they did it is they used the operating system method, the operating system to determine the locale. And based on that, they used the locale definitions that were on the specific operating system. Given this was Siemens Nixdorf, that was fine for them because Siemens client worked with Siemens server, but in general it wasn't good if it was HP client or whatever, and they didn't care about that, of course. But they used the operating system locales. So for backward compatibility, anybody who had that product, we needed them to use the GLS functions, but get access to operating system locales. And the way we did that was not by trying to map the GLS functions to the operating system locale functions, because if we did that, we'd still have the same underlying multi-threading problem. But rather what we did is had the Dublin team create GLS locales that had the same behavior as the operating system locales. So that's how you may see several operating system OS locales. And the customer's free to choose whatever they want, whatever makes sense in the environment. But we provided those for. The problem is that for some reason it can't be exactly perfect. We've had to reverse engineer some of the runtime functions to determine what a locale should look like, and reverse engineering hasn't always been perfect, particularly with sorting and so forth. The types of internationalization operations we support in the GLS library are really the same kind you can find in any internationalization book. Sorting and comparison, not sorting, but comparison upon which you can build sorting algorithms. Uppercase, lowercase conversions. C-type is something printable, upper is alpha, is digit, all those kinds of things. Numeric format conversions from a binary integer or a binary float to a string representation of that thing, and vice versa. Date and time, from string representation to binary representation and vice versa. Date, time, money from character representation to binary representation. Yeah, I think that's it. The thing we didn't do was message files, message file access. The reason why is that Informix, in our Unix products, have message file access routines already in place, and message files already in place. Those were sufficient. I think there were some minor changes that had to be made to support Asian languages, but that was already in place and sufficient. So we didn't even implement those functions from the XOpen standard because it didn't make sense. So how do we get independence between the client and server? When we looked at, well, the GLS library, like I said, is modeled on XOpen functions, which are really at the operating system level. So they're very low level. There's not a lot of software below that you need to implement them. As a matter of fact, when we started implementing the GLS library, we just started with an empty file. We just started writing. We didn't link in with any other objects. It was just from the bottom up. Then as we got to talking with some of the people on, at the time, Shane Zelane's team and the server team, we realized that there were some fundamental differences between the client and server in some operations like memory allocation and deallocation, file access, the way to get environment variables is different with Informix, not different between the client and server necessarily, but different in Informix. So we couldn't use getEnv, we couldn't use malloc, we couldn't use fopen because all the definitions of those functions changed from the client to the server. And also we needed an Erno value. And Ernos and C libraries are global int, and that causes problems in a multi-threading environment. So we needed an Erno value but that error no value had to be implemented differently on the client and server. So when we looked at that range of things, we said, well, we could do like genlib and say if def turbo, do one way, else this way, but we just did not want to have two separate compilations, one for client, one for server. We absolutely wanted to have one compilation. So what we did is, the way we started to do this is to define functions called like GL malloc, or what is it called, GLEXT malloc, or GLEXT free, GLEXT fopen, and fput, and all that kind of stuff. GLEXT getty env. Put calls to those in the GLS library, but not define them in the GLS library. So if you compiled the GLS library without any additional files, you would get undefined symbols for those guys, because we didn't want to assume that we would know the definition of some of these functions. So therefore, we required the users of the GLS library to have a separate file to define those functions and then to link in that file. So if you wanted to include a foo.c using the GLS library, you'd have the link line would look like foo.o, libgls.a, followed by some foo.gls.o, which defined what the malloc routine was, what the fopen routine was. On the client, it was simply glext malloc equals malloc, glext free equals free, but obviously on the server it was mt sh free and mt sh malloc. We had a lot of problems about the ownership of those files, and we gave reference implementations, but when something's changed in the server and they broke, they said, well, this is a GLS problem. We said, well, no. We say we don't know what you're going to define malloc to be, so you tell us what malloc is going to be and change this file. To this day, I believe that it is the responsibility of the user of the GLS library to define these routines. What does malloc really mean for the server? If they radically change the memory management model of the server, they should be responsible for informing the GLS library.
What file? What file is this?
Now, okay, so I'm speaking historically. The problems we had with that file implementation was on AIX and on Windows, you couldn't build the GLS library without having all the following symbols defined. You couldn't just, like on Solaris, it's very forgiving. You build something, you can have a lot of undefines waiting around, and only at runtime could they be linked up, or at link time they could be resolved. Some platforms couldn't do that. And so we thought of doing specials for those platforms, and we said, well, let's redo that whole system. And instead of expecting these things to be resolved at link time, let's have a function that registers other functions. So you say at runtime, before you call any GLS library functions, you could say GL init malloc routine. I don't even know what it is. But you pass a function pointer to that routine, and that function pointer is used as the malloc routine. If you don't pass that function pointer, we will have definitions like malloc and free and getty env and fopen and all the standard C routines. So if you don't override the definition by registering one of these functions, then it uses the standard. So in that way, you can compile the GLS library separately. All the things are defined. We have a runtime overhead there, in that you have to do an if. If you've overridden it, then use this new function. But that runtime overhead has not proved to be a problem. That work was being done as I was phasing out of GLS. So there's some file somewhere that calls these GLS library functions that registers what the malloc should be, or what. I don't know what that is. It's certainly not in the GLS library. It can't be in the GLS library. It's something in genlib somewhere.
Check GLS in it, right?
In one is in genlib, right? Michael ordered those, and server version is in GL MS What other name?
You know, it's funny, it should be in the same file. Because you should say if def turbo, then initialize with these, else initialize with these.
It is.
It should be simple, it should be as simple as that, but for historic reasons, it wasn't, and, so, I don't know what file those are, but, you know, you could look at the GLS library documentation to find out what those registry what those functions to register those routines.
Actually, we're moving to GLS.
The thing is, you got to call these before any GLS library function gets called, because usually the first function you want to do is create a locale, and the first thing that create locale will want to do is malloc some memory, and so you got to have it right, or else you can have disastrous results of doing a malloc, then registering a new free function, and then freeing it with a different free than a malloc. So it's really, it's tricky, but once again, it's only the responsibility of the product, it's not the responsibility of the GLS library. Since some of you own products as well as have interest in the GLS library, then you can see it from both angles. But, and that interface has always been a problematic for us because of the portability aspects of it. I think we finally have it right. But like I said, today, you know, the ownership is such that I bet if there's a problem in there, if the server changes something, or we even change something, and it breaks something in the GLS library, whoever owns the GLS library will be called up and say, fix this, when it's not that way. It's, you know, the people who have to use it have to feel responsible for setting it up. And like I said, this all goes back to the historic impressions that you just simply link with the GLS library, and then all, you know, people sort of thought that by linking with it, you'd end up overriding functions that they were already using, and therefore things would magically work. And that was not the case. It sort of is the case with genlib, because there's been a lot of work to internationalize genlib, and if you link with an internationalized genlib, then when you call a genlib function that used to only be single byte English, it will now work, you know, appropriately, but there's a lot of work to get to that point. So the impression is appropriate for genlib and its and above, but not for the GLS library itself. And I think that's where some of the confusion, even to this day, stands. So let's talk about the use of the GLS library internally versus externally. Originally, we created the GLS library for two purposes. One is to use it to internationalize our own products, so that we can deliver one version of the server, one version of the SQLC that works in all languages, on all platforms, without porting to French on HP as opposed to French on Sun, as opposed to German on HP. You know, the combinatorics are crazy. So you want one product that works in all languages on all platforms. Certainly one source. You know, you obviously have to compile on different platforms, but one binary certainly on a particular platform. And we've achieved that. The other thing we wanted to do was expose the GLS library for use by application programmers. Because just as we want to create one binary that works on all languages, so do our customers. They want to create one application that works on all languages. And they have the same problems as us. If they're trying to go from one operating system to the next, then they're going to have the same problems, and there's no facilities to help them apart from the GLS library. If, of course, they wanted to, we know we have to port our products to a range of operating systems. If our customer has to port their application to, say, only HP, fine. Then they could use the rules of HP, use the HP NLS locale, and everything works just fine. But if they want to be heterogeneous, they have the same problems that we do. So acknowledging that, we worked with a lot of international companies early on, and they were saying, well, what can we do? What can we do in Informix to help them out? And one thing is to expose the GLS library to them. And that's not only helpful for customers outside of Informix, but anybody who is writing an application in-house on top of the SQLC that needs to internationalize themselves, they can use that clean, you know, exposed API documented. But we started with the with the XOpen specification, implemented that, and applied it internally. And that was a lot of work, but we eventually got that done. Then we started looking at what it would take to expose that API out to customers. And also to not only ESQL-C programmers, but also data blade programmers. And this is at the time in Lustra. And we were thinking, well, gosh, we want internationalized data blades, and how do we get that? Well, they have the same problem as everybody else. There's not one consistent API. You'd have to do separate language ports or separate ports to different operating systems, and we didn't want to do that. So we got various representatives from various teams together back in 90, whenever, and put together the definitions of what we needed, and we found out that the function signatures that we really needed were very different than the function signatures that XOpen had defined. Obviously, our stuff was all based on our own SQL data types. The date data type is a 4-byte integer that we have the date in, and it has a certain definition. Whereas XOpen data type is not a 4-byte integer. It's a data structure that has different fields from month, day, and year. We didn't have any decimal functions. We still do in GLS library. But there were various other strings. Within data blades, a string is a pointer and a length. In XOpen and in ESQL for C, it's a pointer to a null terminated string. Two very fundamentally different concepts. So we said, gosh, if we just expose the GLS library as it is, nobody's going to be able to use it. Every time they want to call a function, they're going to have to convert from null terminated string to length, pointer and length, or have to change their dates back and forth and all that. So that was a little bit of a problem in the way we defined the GLS library. We defined it based on an operating system standard where we probably should have stepped back and tried to define it in terms of an SQL standard. Although at the time we were thinking that if the different operating system vendors ever do agree on a consistent API across all operating systems, a consistent locale system across all operating systems, and a consistent locale definition across all operating systems, then we wouldn't need the GLS library. We would simply, where we called the GLS library before, we would call this new, universally agreed upon API. So we didn't want to waver too far away from the standards that we saw, or at least the XOpen standard, which we thought was the most likely to win. But we paid the penalty of being farther away from our own internal data types and so forth. In retrospect, it was the wrong decision because nobody has gotten together and agreed upon a single API for all operating systems. We didn't. There's no opportunity to say throw the GLS library out and replace it with this other thing. Of course, SMT, Windows, everything is one operating system. Then we could do that. Until then, we're stuck. So we had to relook at the whole API, the whole GLS API, and say, well, this is not the API that's used internally is not the one that we need to we should expose externally. And so there were some fundamental decisions that we made. Any function that took strings as arguments that you used to take an null terminated string would take a string, take a pointer and a length, and if the length was 0 or greater, that would be considered the length of the string. If the length was -1, it would be considered then a null terminated string. So we didn't want to create two different functions, two different versions of every string function. It's a runtime test, but underneath there's two versions because obviously you have to perform different algorithms underneath. And we did perform, in many cases, perform two algorithms because we didn't want to say if we got a pointer and a length, we couldn't null terminate that because we didn't know whether we'd have space for the null. Or we couldn't say if it's null terminated, simply calculate the length because that's a performance overhead of running through the string to define the null and then perform the operation. So in many cases we have an if to say do this completely different algorithm for null terminator as opposed to pointer and length. That was one change we made. Other change we made is for some fundamental SQL data types like date and maybe this is date and date time. I think instead of using the xopen definitions for these values, we use the Informix definitions for not only input but output. In those situations, I don't think we fundamentally rearranged our algorithms. I think we just did the conversion, the Informix version of date to our version of date, and then taking over the GS library. And then I think the major decision, which I think is causing some of the data blade people some problems, is I think Bob and you talked about this. Every GLS library function up to that point took a locale as a parameter. There was a decision that, oh, that's pretty clunky. We'd have to then expose the way for the programmer to get that locale variable. And for an ESQLC program, there's only going to be one locale as an assumption, and therefore that one locale can just be referred underneath the covers by the GLS library function. Looking at like TCBs or SCBs or wherever the locale would be stored. And so none of the GLS library functions exposed to customers take a locale as a parameter. So with those major changes, no locale parameter, using SQL data type, or at least Informix proprietary data types for date time, and even float, I think. I think everything we had was double, and there were some places where we used float. And then for the strings, we decided, well, we couldn't change the interface of the GLS library. So all these functions that we originally wrote, which were GL underscore something, we kept exactly the same. We didn't change their interface whatsoever because we had people out there that were using them internally, so we couldn't change them. So we had to add new functions, which were veneers on top of those functions, which had all these new characteristics, as I was saying. And we called those the IFX GL functions. Those are the functions that are documented in the, I don't even know what it's called. It's not called Guide to GLS Functionality. That's the document that is this.
The GLS Programmers.
GLS Programmers Guide or something like that. That's shipped with the client SDK. That defines documents all those IFX functions. Underneath those IFX functions, like I said, are all these GL functions. So if you'll know right away if somebody says, I have a problem with this IFX function, you know that they're coming in from the outside.
If they come in from does the IFX call, the IFX GL so-and-so call the GL so-and-so?
In most cases.
In most cases.
Yeah, well think, yeah, we'd have to look up maybe a simple case, but let's take a function that has a character string, an IFXGL function that takes a character string and a date and no locale, obviously. So what that would do is first thing it would do is find the locale from, like, there's a macro I think called proc locale or something like that that refers to SCB arrow something, it's a value field. So underneath that, it gets the proc locale. It will convert that Informix date value to xopen date value, and it will check the string. If the string is a null terminated string already, then it will simply call the GL function with the locale that it got, with the new date that it created, and the null terminated character string. If it's a length terminated character string, then it will call a function that never existed before when we just had the GL functions, because then it will have to go pointer length and do that kind of determination.
Okay, so the pointer length.
Pointer length is,
That
It's
was-
a different way of traversing the strings.
That was the extra way that was added
Yes.
to support the data plates.
Yeah, that's right. That's right. You don't use them in ESQLC unless, maybe the application has a pointer length string. You could do something with that. But certainly ESQLC itself, I don't think, if it has any instances of that, it's few and far between. Basically, it's an alternate string. So in most cases, the IFX are just veneers on top of existing GL, with the exception that in the pointer length case, it has to do something different. So if you see some functions that somebody complaining about a GL function, then they should be using that in an Informix product, not in an application. And if they're using an IFX GL function, they probably should be using that in the application and not in Informix. You certainly wouldn't use the IFX GL to implement the SQLC for multi-threaded purposes. When we got to date and time, we found out some unfortunate things. Because of backward compatibility, there were quite a few algorithms, like for example the DB Century algorithm, which we needed to rely on in the GLS library, but was already implemented in ESQLC and GenLib. So we had the alternative of taking those algorithms out of GenLib and putting them in the GLS library and having GenLib use them from the GLS library. Or we had the alternative of putting them in a separate library and referring to them. The way we did it was we just kept them in GenLib, and then, and I think this is particularly just for date and time, is that the GLS library, some of the IFX GL functions, because they require tight integration with Informix data types, and they have this backward compatibility, some of the IFX GL functions are not actually implemented in the GLS VOB. They are actually implemented in GenLib. So there are some C functions in GenLib that are called IFX GL or whatever.
IFX GL and NIT, I think. I noticed is in
Well,
no, that's not the same case.
Could be, yeah.
Or something.
But yeah, yeah, in NIT, right? I can talk about that for a second. But the date and time stuff, we just had a horrible time. This is sort of getting back to I think some of the problems that we may have seen in like DB Access with that floating point R-type width problem. We expanded we fixed a bug and expanded the definition of something in ESQLC that created a backward compatibility problem. Not because the old way was the right way, but it just was the way.
The only way.
Yeah, the only way, and the documentation wasn't clear on what the right way should be, so tests and customers rely on the old way regardless of whether it was right or not. And so by re-implementing that piece or generalizing or fixing that bug, you create this legacy thing, and then that freaks people out. And so we had a huge problem with that in date and time, and so that's one caution, that any change in date and time, because of the general undocumented nature of it, people are really relying on the way it has been implemented. Probably that one problem. IDC was exactly that instance. We try to do the right thing by generalizing it and doing the right thing from the internationalization point of view, or doing something wrong from a backward compatibility. So for that reason, we had to rely on a lot of the algorithms for date and time that are actually part of GenLib. In it, when we were using the GLS library to implement, to internationalize the server or ESQLC, it was never exposed to the customer. So one of the things you had to do is initialize it, in other words, load the locale that was, there's these environment variables that are used by the server and the client locale and DB locale and server locale. Those aren't defined by the GLS library, but you have to have a locale for the GLS library to operate on. So what is that locale? It's the locale that's loaded by some initialization function. So check GLS init, I think, is the name of the function. say on ESQL. Well, in the server, it's easy. When the server starts up or database is created, when a database is created, you look to see what is the DB locale, and you load the locale, and then you operate on that database. So there's a very clearly defined initialization point, and so there's code in there to initialize, to load locales and store them away so that the server can see them for the rest of the connection to that particular database. On the ESQL for C, it's not so clear, because you can write an ESQL for C program that says main curly bracket and then immediately call a internationalization function from, you can call a function that does, we're in a case conversion function, R case conv or something like that, I don't know, some alphabetic case conversion function. There's no database connection, no anything, you can just do that case conversion function. And if you haven't initialized the locale, you're passing a null pointer to the GLS library and it'll blow up. Oh, as a matter of fact, early on, there was several problems where people said the GLS library crashed. When we looked, they were passing a null locale pointer to the GLS library. And people were saying, well, they didn't do the investigation. They didn't even do the due diligence to find out why it was failing. Then when it was failing, they were saying, well, why does it fail if you pass a null pointer? Why doesn't it just return or something like that? Those were the same people that wanted the GLS library to go very fast. And so if we had all these checks and balances and all that stuff, go. So it's just, my argument was, if you pass a null pointer to strlen, what does it do? It doesn't check and then fail gracefully. It says, I assume you're going to pass me a valid character string pointer, and if you don't, it's going to blow up. It's really good. Also, remind me to talk about performance after this thought. But the initialization on ESQL-C meant that any function that the customer can call that eventually would call a GLS library routine, we had to put at the top of that function, make sure that the GLS library is initialized. Because we didn't want to put the responsibility on the customer to initialize a locale, because they may have had an application that already worked before. It had no initialization function, just started doing things. We didn't want to put a responsibility on them to initialize the GLS locale. So any locale-sensitive function, or any function that eventually called a locale-sensitive function, had to have this check GLS init at the beginning of it in ESQL-C. And still to this day does. Which is that was a real pain, because you have to find the whole tree of possibilities and work your way up. And they're very error-prone, and who knows, maybe there's some problem there we don't even know. Although, probably not, because English behavior is defined via a locale also. There's an English locale. It's not like if English, then do this algorithm, else then call the GLS function. Most of the time it's call the GLS function and it will do English itself, because it's pointing to an English locale. When we expose the GLS library to ESQL for C programmers, then they could call any one of the IFX GL routines. And we didn't want to have in the GLS library a responsibility to load a locale, because in the GLS library we didn't know what the locale was. We don't know anything about what client locale means or anything like that. So by exposing it to the customer, we had to put the responsibility on them to say, if you are going to use the GLS library, you have to call IFX GL init or something like that at the top of their, well, before they call a GL, a locale-specific function, because then all the locales have to be set up, because this global variable had to be in place. Or at least it's thread specific.
Did you consider doing it for them, in the sense of having IFX so-and-so function call to make sure the locale is initialized, and then going off to the GLS library or whatever?
Well, some of the IFX, also some of the IFX functions were in the GLS library itself. So take IFX GL string compare. You're comparing two strings in a locale-sensitive way. That is defined completely within the GLS library, and has no notion of what client locale is.
Wait, I thought that if it was in the GLS library, it would be underscore or GL underscore string compare, and then if it was IFX. Then it was-
No, let me go and clarify that point. The majority of the IFX GL functions are defined in the GLS library. There's these exceptions that I mentioned, which
Okay,
are some
those are the
date and time
exceptions. I'm
functions.
sorry. Okay.
They're exceptions that are implemented in GenLib because they themselves needed access to routines that were only available in GenLib.
Okay.
The other alternative for those functions we could have provided was give me a pointer to the DB Century implementation function, and we could have done the same thing we did with malloc and free, just to say the GLS library doesn't know how to do these things, it will call an external definition. But when we looked at how tied together they were, it made more sense to do them just in GenLib. But those are the minority of the IFX GL functions. The majority are actually implemented in the GLS library, which has no notion of the environment in which it's running. So there had to be this IFX GL init, which is defined in GenLib, as you mentioned, which will load the appropriate locale from client locale and then make sure to put that in an SCB or TCB or whatever, and then make that available to all subsequent IFX GL functions. If the customer is not calling the GLS library directly, they don't have to call IFX GL init, because all the check GLS inits that were in before are still there, so that the locale will be loaded if they call the standard GenLib functions.
Is it possible that they would become, sort of, without really realizing it, not have to call IFX GL init by calling some GenLib routine that had called check GLS
Absolutely,
and then
yes.
they're safe, right?
Oh, yeah. So they could be lucky by one of the first things they do is calling a GenLib function that initializes the locale. Don't call IFX GL init, then call IFX GL string compare, and then everything would work. Because you only have to do this initialization once, and once you've done it, it's fine. So anyway, that's why. In the DataBlade world, we define IFX GL init for them, but it's a no-op. Because for DataBlades, that locale already has been loaded. The whole environment for DataBlades linking it, it's not, DataBlades are not main curly bracket, they don't begin. There's a lot of other stuff that's happened before a data blade gets invoked. One of those things is that the locale gets initialized. So while we wanted to keep the same interface for both, so if you wanted your application to work both in the data blade, or you wanted a snippet of code to work both in ESQLC and the data blade, you'd preface that with IFX GL and init, and you wouldn't, it would just be a no-op.
Where's the no-op defined? In the data blade?
No, it's in the server. Just as ESQLC defines IFX GL in it, there's a server implementation of IFX GL. If it's in GenLib, it's probably something like if def turbo, don't do anything else, do check GL in it. The use of the data blades, some of the data blades are starting to use the GLS library more aggressively, and they're finding out some problems with data types and the application of the GLS library and so forth. And so we did the best we could with the verbal definitions that people gave us, but now that people are actually starting to use it, albeit 2 years later, they're finding some problems, and Bobby's been aware of it, Mary. Remillard has been aware of it, we're working on those. That's certainly in terms of performance, the first implementations of the GLS library were slow because, well, they weren't slow for multi-byte locales because that was the worst case, and that's the best you can do for multi-byte. We actually optimized very heavily for multi-byte. If you had multi-byte character strings, we optimized very heavily for that and made that go as fast as possible. The first implementations of the GLS library, for simplicity's sake, had the single byte English going through that same algorithm. So obviously multi-byte is, you can guess, it's a loop. if this is the first byte of a multi-byte character, then go through the loop a second time. Is this the second byte? Yes. Are there more bytes? Yes. You keep going through that loop. For English, you would never go through that. You'd only go through that loop once. You'd say, I've got the character. Is there another byte? No. Then you just drop through. But the determination of is there another byte and so forth was time consuming, and that caused some concern for people who were running benchmarks. So our response to that was, well, first, not every GLS function is used in a way that requires heavy performance. So let's identify those functions that require heavy performance, and let's figure out how to optimize those. And the way we optimize those is we know in the locale. Well, when you load the locale, you can know the characteristics of that locale. So what we changed the locale compiler to, when it compiled the locale, to do some analysis of the locale, to find out, was it a single byte locale? Did it use binary comparisons, like the strcomp algorithm, simply comparing bytes, as opposed to a natural language algorithm which would look at the character and do a lookup table and say, does a umlaut come before or after a? There were some other characteristics of a locale that we looked at.
This information is not in those files that are the text file that locale compile.
No, they're not. It's not like Pragma. It's not in the text files. It's in the binary files. So the locale compiler takes these text files, which were defined the way they've always been, analyzes that, because at compile time you can do any kind of analysis you want. It's like minus, well, it's not like minus O, but
So
something.
the information is not there in the files. You have to somehow gather different information through your analysis.
Right.
It's not directly.
No. Well, because if you had something like Pragma, you could say Pragma single byte, but there's nothing that keeps you from defining a multi-byte. So instead of trying to match up somebody's idea of what it should be with what it actually is, the locale compiler said, well, are there any multi-byte characters here? No. So it's a single byte locale. Are there any, what is the comparison routines? Is the comparison based on byte order, or is it based on actual natural language order? If it's based on byte order, then set a flag in the locale, the binary of the locale, that it has this characteristic.
How do you call those files that locale compiler take?
Well, okay. The .lc files are the locale source files. The .lco are the locale object files. So the .lco, we call them objects and binaries, but they're actually, we wanted them to be portable, so we put them in like a text representation. I mean, analogous to UU in code. We didn't want to do any compression. We didn't feel we needed to do compression. But it's, you look at it, it's actual text. It's ones and zeros and new lines and all that kind of stuff.
So the LCO is compatible across platforms?
Yeah, you can take an LCO and move it anywhere you want.
Cool.
It's like platform independent. You can move it from Unix to NT.
Unix to NT from byte ordering doesn't matter. 64-bit doesn't matter. Because we knew that, if we just wanted to avoid all those problems. And also we wanted to make it readable for debugging purposes. We didn't feel like, well, as soon as you go to binary, then you introduce the issues of byte ordering and all that kind of stuff. So it of course slows down the loading a little bit, because if everything was binary, you could just pick up 4 bytes at a time, maybe 2 bytes at a time, and just load it. But we figured that locale loading is going to be something you're not going to be doing frequently. And really the way to solve the speed problem there is to cache the locale. So once you load it, don't load it again. The way we felt is that you're not going to load the English and the French and the Spanish. You're not going to load like 50 locales. You're going to probably load 2 locales.
But that's on the server side, right? Loading of the locales.
No, it's on client
Client
side
side too.
Whoever needs a locale.
What
If you are a separate process that is using the GLS library, you need your own locale loaded into
Right.
your main memory.
But on the server side, let's say for example, if there are many clients, right, who are operating in different locales,
Yes.
then it's a problem, isn't it?
On the
Because-
server.
on the server.
Yeah, it could be a problem, sure.
Probably
But
you just need multiple locale.
Right.
well, the server, what we did was we implemented a cache,
Okay.
basically a linked list, and said, I need locale X, I need French. So it looks up, is French already there? No, load it. Okay? Next time, I need French. Is French already there? Yes. Just return a pointer to it. Locales are read-only, so you know you could have 100 pointers to it. And, you don't have to lock access to them. And actually, I think the server does a simple thing. There's no garbage collection or there's no reference counting. The way we figured it with the server is that you're not going to load that many locales. And even if you loaded every single locale that existed, it's a finite number.
Right.
You're not going to get into this loop.
Right.
Maybe you want to load the French locale a million times, but the way we had it set up is that you wouldn't load it. You just you get a pointer to an already loaded thing. So there's no cleanup on the server. It just leaves it there, which is, we've never had any problems with that. Because, very rarely, you'd probably run out of connections before you'd run out of memory to load these to the different locales. Because the only locales that cause problems are the Asian locales, and there's only Japanese, Korean, Thai, Chinese, and Taiwanese. So that's all you have. So,
At runtime, we need the local object file and also cosec conversion file. These are the only two objects that we need.
Mhm.
And cosec is what is it related to locale?
Okay, let me describe it. A locale consists of a language, territory, and code set. It's French in Canada, 8859-1 code set. So the language is French, the territory is Canada, and the code set is 8859-1. Code set being, the code set doesn't matter to the natural language. It's just the binary, what is the bit patterns to represent A, B, C, D, A umlaut, A accent, A graph. French in Canada is different than French in France. I think, for example, the date and time format is different. So it's not just French, it's French language territory. And you could also have some modifiers. You can maybe say German in Germany, 8859-1 code set, Bundespost sort order. There's different sort orders, a postal sort order and a phone book sort order in Germany and some other sort order. So, locale consists of language, territory, and code set. If you have French in Canada on your server and French in Canada on your client, those will be able to connect, regardless of the code set that is used. So, for example, say your server is French in Canada, ISO 8859-1 code set. And your client is French in Canada, Microsoft Windows 1252 code set. Both of those define roughly the same characters. And I say roughly, and I'll get back to that issue. Roughly the same characters. So if you're transmitting data from the client to the server and the server to the client, you can do that, except you have to convert. So A may not be, well, A's not, A umlaut may be represented as hex C8 on the client, but represented as hex A3 on the server. So if you passed C8, it would not look like A umlaut. It would effectively corrupt your data. So you have to do code set conversion. The association of the algorithms of the locale and the algorithms of code set conversion, there's no association really whatsoever. Converting from one code set to another is based on the definition of one code set to the other. The association is that every locale has a code set. So your client locale will be French, Canada, 1252. Your server locale will be French, Canada, 8859-1. The locale has to know how the characters are represented. The code set conversion has to know how the characters are represented. but the process of code set conversion is very different. So the code set conversion files are simply a mapping. It says this bit pattern in this code set maps to this bit pattern in this code set. This bit pattern in this code set maps to this. So it's on and on, this big table. And in code set conversion, there's no semantics. There's no interpretation of is it alpha, is it digit, what is the comparison routines. It's simply how do you represent a umlaut in this code set, how do you represent it in this code set, and the mapping of these big patterns.
So a code set is, a conversion is one locale to another locale?
It's one code set to another code set.
I mean, one code set to another code set.
And vice versa. You know, if you're going from, you're passing data from the client to the server, you code set convert from 1252 to 8859-1, for example. And then when you send the data back, you're going to go from 8859-1 to 1252.
One locale corresponds to exactly one code set.
Mm-hmm. Right. So if you say, I have a locale in my hand, you have something that is defined by a language, territory, and code set.
So if this client has that 8859 locale or code set, and then the server has the Microsoft one, the client needs a code set conversion table that says how to get from the 8859 to the Microsoft one.
And back.
And back.
Both code set conversions happen on the client.
And that's one file that says how to go back and...
No, there's two separate files. Because when we talked with the gateway people, they had some situations in which they had, at the time, they had gateways where they only were getting data from the IBM mainframes and never putting the data in the IBM mainframes. So they had no definition of one of those directions for gateway technology because they use the same kind of thing. Whereas for client server, obviously you got data, character data going to both.
So a client has to know every potential thing that's going to connect to the
for the code sets that it can support. Yeah.
Every potential one that it's going to connect to, and have a code set file or a
code set conversion to
code.
It's loaded whenever it is needed. Right?
Is it?
The locale of the code set.
Yeah, well, okay, so when you check GLS init, it says, here's my client locale and here's my DB locale. Even though the DB locale is defining the database locale, it's still set on the client and passed to the server for this reason, is that you set your client locale and DB locale, I have to do my code set conversion. What am I going to code set convert it to? I'm going to code set convert from the client locale to the DB locale. Better load that code set conversion. I'm going to code set from the DB locale to the client locale. Better load that code set conversion.
So the code set conversion happens on the client.
Both directions, yes.
Okay, so the server does not know anything about code set conversion.
With one, well, there's two exceptions generally. Generally, for client-server connections that we're familiar with. Two exceptions. One is that the server writes out information like, not log files, but it writes out some files. There's a thing called server locale, which will take it, in which you got data in the database that you want to write out to a file. The code set of the file that you want to write out is, the file's not on your client, it's on the server. So you may have to do code set conversion between that file on the client, in the database, the data in the database and the file on the server.
Okay.
So there you may have to load a code set conversion. The server may have to load a code set conversion for that purpose, not for communicating between the client and server.
So the server locale is only for the server to write data to some
server.
file?
Yes.
Or some information?
Yes, on the server, right.
So-
Not writing it to the network.
Okay, so in case, let's say for example, you don't want any information from the server, I mean, you should not be worried about the server locale. Right. Okay, so the important thing is DB locale and client locale.
From our perspective.
From our perspective.
So maybe, from other people's perspective, the client locale, server database locale may not be important. The server locale is, but from our-
UDR.
Now, that's the second exception, is that the Illustra model for data conversions, not just character conversions, but any data conversions for a data blade is for UDTs, the server does the conversion.
Okay, for UDTs, the server does the conversion?
Yes. That's for floating point format, that's for, well, UDT's got several converters. There's, what is it, send, receive, what was that? Send, receive, or put, get?
Send,
Send,
receive,
receive, input, output, import,
Import,
export, import binary, export binary.
Yeah. So obviously the server side of that is responsible for all those conversions.
Okay.
And therefore, but that's already been worked. Gil Pratt at that time worked with the data blade people for at least the base types, char and nchar and nvarchar, all those base types, to put in the appropriate send receive functions for those base types to do the code set conversion that was necessary.
So within a UDR, can the UDR find out what is the locale on the client side?
Yes. Yes.
You get the DB
DB locale and client locale.
locale.
Within
DB
a
locale
UDR.
actually is,
I
I
don't
need
think
to set in some flag in SCV.
Boy. That's where I started. You know, that's where I started. Looking for another job around that time.
Because I have a bug, that's the reason why.
Is that not part of the connection information? When
That
the
is
client
sent
connects to the
to-
server, it should pass on its.
Well, okay. I don't know what the mechanism is, but I know. Talk with Gil.
Okay.
If he doesn't know, then he knows where it is documented,
Okay.
or he knows where it's implemented. So in the worst case, you got to go and look at the code, but I think it's already documented as to how that works. But I'm not. Eileen Mustaine obviously knows some things.
They have a lot of problems initially. They didn't understand the semantics of DB locale.
Oh yeah.
Basically, each connection is sent with the memory variables to the site and do a cache boundary. So the second.
Okay. So those are the two situations in which a server could do a code set. Server side could do a code set conversion. Anything more? We want to get back to performance, but I want to make sure we want a code set conversion.
So the server is doing code set conversion because some of the data it's writing to the log files or the message files involves client supply data.
No.
Why would
Let's,
it
okay,
care about
let's
code
think about text files. When you pull up VI or WordPad or whatever, that thing understands a certain code set. You know, maybe in your careers you've gotten a file from somebody in another country, say even just a European country, and you load that under your English VI. You know, you get all this garbage. You get some English characters look right, but then there's a lot of garbage. Okay. So say there's this text file, and you want to write a text file to the client. What is the environment that your client is operating in? If your client is operating in French 8859-1, then you want to set your client locale to 8859-1, French 8859-1. So anything coming from the server will be code set converted so that when you write something out to a text file and then look at that in your WordPad on your client, it looks right. Server has the same thing. It could be on a client server, of course, could be the same machine, but it could be a separate machine. So the server, like say you have an HP server, and you want to write log information out to a text file that you want to eventually start up on a VI session on HP. Well, you have to use the code set that HP French is implemented in for that VI to work. So you want that log information to be written out in that code set. Now that log information may come from a database server that got its original information from Windows PC. So the data in the database, just because the database is sitting on an HP, doesn't mean that the data is encoded in any form that an HP system can understand. It could just be, like this is going back to my comment before about the database server shouldn't be so tied to the operating system such that when you store data on an HP server, all of a sudden it becomes so HP-ish that you can't access it from anywhere else.
But when the server receives the data from the client, would it not convert it to its own
Doesn't have to.
code set at that time before it
You
puts
could.
it in the
You don't
database?
have to. You could. Now, this has nothing to do with the GLS library. So I'll tell you, this is exactly the way things happen, you know. It starts drifting away from the library itself, and then that's how, you know, people start asking these questions, and then they say, well, fix it in the GLS library. You're like, whoa, we're just miles away from the GLS library. Okay, so client here, 1252 Windows code set. Then you got the server here, database here. You're still, can I move it? Okay, still there? Okay. Okay, so this is sitting on, say, Windows sitting on HP. Okay, so you have, this environment is, 9-1 is the general environment of the machine. So we get a text file here. So this is writing out to a text file. Okay. The client, here you would set client locale. To 8859 or sorry, 1252. You could set your DB locale here equals 1252. You could set that. And so there's no code set, you got an opportunity to do a code set conversion here, but because the client locale and the DB locale is the same, you don't do the code set conversion. This 1252 data, you can write that out to a text file and read it in WordPad, everything's fine. You can store that 1252 data here, okay? And then access it, say you wanted to access this, the same database on Sun, IBM AIX, which used 8.9.
Anything.
Yeah, 819. And you wanted 819 here, 819 here, and a text file. If you wanted to access the same database, you'd have to do a code set conversion here between 1252 and 819. Here's 1252, 1252. So here you'd have to do a code set conversion. Regardless of whether you know what this is, because the database server is neutral. It's like saying when you store a video clip from Windows into here, just because this guy does Microsoft AVI and this guy here does QuickTime, it doesn't mean that you're going to convert it to QuickTime. You're just going to store it in AVI, and you know. So this is the server and database server should be and is neutral, or could be made neutral depending on how you define your DB locale. So now say there's some log information that needs to be written out that's derived from the database, and say you want to load that file on an HP system where your VI understands 8859-1. So 8859-1. So you'd have to do a code set conversion here between 1252 and 8859-1.
What if there is no code set conversion possible? Would you get an error? Or?
Yeah, oh yeah. Because if you don't, then you can't just pass it on a door. If you say, I want, my code sets are different, and you don't do any conversion, then you're really screwed, because then it's data corruption, effectively.
Do we do that, or do we cater to the situations where we can map most of the characters, but some of them are identified?
Well, okay, now, yeah, let's get back to that, which is, I said, in most cases, it's a Venn diagram, you know, you've got code set here and another code set here. Some code sets are, well, there's no code sets that are like this, that we care about. There's always at least this where A to Z and 0 through 9 plus the punctuation. At least there's code sets.
Don't they all share ASCII 7-bit?
Yeah. Well, if you if you're talking purist, IBM mainframes, whoa, I mean, that,
Okay.
you know,
Absolutely.
there's,
Right, okay.
yeah. It just, or some, some countries started by having code sets that had nothing, I think Taiwan, some had code sets that had nothing but Taiwanese characters in them, so there's no intersection. Code sets like this are really of no interest. I mean, why would you ever want to have those in the system? Because presumably you have this code set because you not only want these characters, but you want these, and you have this code set because not only do you want these characters with these. So what does it mean to have a code set here convert between these two code sets if the only thing you really share is ASCII? What is it? It doesn't mean anything. You could do that. You could define a code set conversion, but what does it get you? So these are examples of code sets that are, like this, where most of the stuff is in common, but there's a couple characters that are in 1252 that aren't in 8859-1, and there's a couple that are in 8859-1 that aren't in 1252. That is a possibility, particularly in Taiwan. There's wide disparities in some of the code sets. We're not talking about a couple characters, but a couple thousand characters that are different. But in the GLS library, even in the Dublin people, there's nothing you could do about it. I mean, take the example of a WISE terminal. It's hard coded to support a certain character set. And no matter how badly you want that A umlaut to show up on that screen, it's just not going to show up on that screen. Same example with a font. The font is just simply not going to show up on that screen. The character is not going to show up if the glyph doesn't exist in the font. So the best you can do is if you have data on one side that you absolutely have to have on the other side, then you have to have either the exact same code set or a code set that has exactly the same characters. But if you have a code set that has exactly the same characters, the question is, why do you even have a second code set? What is the whole point? Why would you have a second code set if all you're doing is representing the same set of characters in a different fashion? It doesn't make any sense. So, very frequently you will have two code sets that do not share exactly the same characters. And there's different ways to handle that. That's an academic thing that I've gotten in various arguments with people about. And the only answer is if you got a code set here and a code set there, what's the best you can do? You can either do one of two things: map it so that you can ensure a round trip, so that when you send a character here, it comes back here. And you can only do that round trip if both code sets define the same number of characters. So if you have a code set that defines 256 characters here, and you have another code set that defines 2,000 characters here, there's just simply no way you can define a round trip, because when you go from the 2,000 to 256, there's only 256 slots, so you can't do this. So there's various problems with code set conversion, none of which have anything to do with the GLS library remains neutral on that, except for informing you about extraordinary situations, but those extraordinary situations are defined in the locale file, in the code set conversion file. You can define a code set conversion file that says, if you've got this character, I'm going to map it to this character, but that's not really the same character. There's a problem here, and then it sets a flag. The GLS library routines look and see if that flag is set. If it is, it sends it back to the caller of that function and lets the caller worry about it. So the GLS library remains very neutral on the issue, as it should. Okay, so like I said, this had nothing to do with the GLS library whatsoever. This whole DB locale, client locale, server locale, all that kind of stuff is the only place the GLS library comes into play in here is right at these places where we define code set conversion. For Java, type 4 JDBC, in talking with Sheng and other people, it looks like the only thing we have to do is code set conversion. All the other things, multi-byte characters, there is no such thing as Asian characters are handled using Unicode in Java, so there's nothing we can do about that. We just implemented Unicode, and it's good. It's actually very good. So there's no need to use the GLS library for traversing multi-byte character strings. There's no use for using it for Unicode because Java has all those routines already there, and it's portable and all that stuff.
Assuming they all use Unicode for, right? If they only use a different locale in their program.
You can't, well, a locale is language, territory, and code set, okay? Java says the code set is Unicode. So French in Canada, Unicode. French in France, Unicode. English in the US, Unicode. Taiwan and Taiwanese in Taiwan, Unicode. Everything is Unicode. Whether you know it or not.
All the different locale does it subsume. But Unicode only has like 63 keys, right?
Oh, right. But, well, yeah, two bytes.
Right.
65, 36 different characters. I know from Taiwan that there's the possibility that that might not be sufficient for various reasons, but that's the way it is. It's not ours to argue, and that's a good thing. I mean, if it's not good, it's not good, but it's the way it is, and so.
So we only need cross-check conversion between Unicode and that specific locale.
Yes, basically Unicode and every other locale. Because our database server can be any locale. So we need code set conversion between Unicode and every other locale that Informix supports.
But our server doesn't support Unicode, right? Does it?
No.
Unicode data plane.
Yeah, Unicode data, right. Right. So we sat down with Zelaine and all that and said, okay, one of the ways we can support Asian languages is to make everything that used to be char effectively be short, an integer. You know, char is a 1-byte integer, short is a 2-byte integer. Make everything that's char, short star, unsigned short star is our new character string. Our new character is short, single character. We never even got past the initial stages of that discussion because there's just too many places in which those assumptions were. First of all, assumption about a single byte null being the end of the string. And so Unicode, a single byte null could be a first byte of or a second byte of an actual character, not a null terminator. Null terminator is 2 bytes, 2 nulls in a row. So we just never even pursued that. And we said, well, we'll make the server support multi-byte code sets. Now, there is a multi-byte code set version, a multi-byte version of Unicode. So the same characters, all the same 65, 536 characters